Welcome back. In this video I'll be solving Leetcode problem 3356, zero rate transformation 2. So you're given an integer array nums of length n and a 2D array queries where queries is L, R, and a value. Each queries represents the following action on nums: decrement at most. Okay, decrement each at value this by this. Okay, the amount by which each value is decremented can be chosen independently for each index. Okay, just more than one. Oh. Well, I can do it queries times n, but this is possibly a lot. Yes, 10 to the 5th times 10 to the 5th, so that's 10 to 10, and I suppose that's too much. Interesting. So let's represent the first k queries in sequence. Well, I have to check. I don't see any other way. Let's try that way then. Okay, I think I actually have an idea. So this one, is it medium? So essentially we can do the same thing as last time. So the last one, zero rate transformation 1. But instead of using all of them, I do binary search number of times. So I binary search a number of times. So first I try with half. If with half it doesn't work, then I know I got to continue. Okay. Whoa, this one will be interesting. So, let me think about it. Yeah. So if it's already possible, then I want to try less. If it's not possible, then I just take Q and more. Wow, this will be hard to do. So let's do the logic for the number of times. Okay. Q's is one of queries. Okay. So this will be log n times n plus q, I think, or something like that. Or log q actually times. So q times log q plus n. Or no. Log q times q plus n. If I'm right. So let's try to get this one. Okay, so I have a queries. Do I want to have checkpoints? Yes, I can have a checkpoint, so I can save time on that also, because if I have to go back, there is actually no need to go. Or is there a need to go back? Because then I need to store a lot. I need to store. Yeah, that's too much to store. So I would need to store for each q. So q times. Yeah, this is memory. That wouldn't work. That would be memory out of range, because I would have to do 10 to the 5 queries of size 10 to the 4. Yeah. Okay, let's not do it like that, and just continue with this. So okay, I have a line of queries, and I'll have on left is equal 0, right is equal this. Let's implement all. So this will be a long one. But yeah, let's do it. I'm kind of tired a bit, but let's get into it. So what I would do, I have a left, I have a right. So it has to be at least one. No negative. Okay, so this will be inclusive. So if I have 2, this will be 2, 0, 1. So while left is less than right, and they're the same, then I'm out. And I found 1. So if left is less than right, test is equal left plus right. This will be a crazy one, divided by 2. So if I have 3 elements, then it's 2, 0 plus 2 is 2, it's 1, it's always middle or the left one. Okay, then I have to do, def test, not test, but 0, 0, 0 try, whatever, 0 try, or let's call it try. I'll call it advance. So I do k, and this is how much of them I have. And I'll text k and k plus 1, and that's how I'll know. So I have to return k. Okay. For I in range can see where is it? Size of version SQL queries. Okay, in range k. So first it's all 0. Range k minus 1. So can k be 0? It can be 0. Yeah, let's do it like this, and k will be test plus 1 always. So k minus 1. I'll see more about this one. So I have line sweep is 0 for in nums. Current is equal, or let's leave it for later, or no. Yeah, I need it later. What I need here is just left right is queries of I, and line sweep of left is plus equal 1, and this is the band 0, and ls of right plus 1 is minus equal 1. That's that part. Now I have to check if this one works. Let's go with test1 is equal okay, and for I in range len of nums, so this one has to be false. For I in range len of nums, v plus v plus v, and that's my bad. Here I need current. Current plus equal line sweep of I. So if current is less than so if it's, well, I need it one time not to be sufficient. I'll have to do it 2 times either way, so let's do it normally. So test if current is greater than nums of also I, and I continue. If not, I'll return false here. Okay. I don't need test one, so test one is true. Now I need to do, I need to remove the kth, so I need to do ls of queries of k. Well, if it's k, then it's k minus 1. 0 is minus equal 1. plus equal 1, and I need to do the same thing. Oh, plus, well, okay. So, and now if this one is first time not, return true, else continue, return false. So something like this. So while left is right, where is -1? Left is this one, while left is less than right. Test left plus right. Well, now I'll need to do this a bit better, most probably, but let's just continue. So test is this, and an example, let's call if advance. Should I repeat this? Well, I can repeat it, this is not complicated. I can just return true here and do it again. So here I actually know if I have a possible solution. So if advance of test if let's say this, test is equal 0, or advance of -1, and here it's not, and advance of test return test. This is it's kind of weird binary search. This is exactly what I'm searching. So there are two possibilities. Yeah, let's do this normally. So in this case, I always want to save the one that worked. So while left is less than right, test is left plus right divided by 2. If advance of test, then left, then right is equal to test, and continue. Else, if this is not true, I know that left has to be test, and that's it. Well, that's it essentially. Something like this. And I do this up until left is equal right. So let's say I have 2 of them. So I'll do it like this. So I have only 2. So this is 2, this is 0. Test will be 1. And this, let's do it like this. So test will be, right will be 1. Left will be 0. So 0 plus 1, 1 divided by 2, that's 0. If 0 works, if test is equal 0, turn 1. Something like this. I can just break here. So if this is true and test is 0, then I break, and then test is 0 and advanced test plus 1. Okay. If right is test is, let's say, so it was 0 and this time it was not right, so left is equal to test, that will be again 0. Well, if test was not good, then left can be test plus 1. I can also use this. That could be it. Let's try it out. So, see a mistake. Well, this works. What happened? So these two were they enough? No, it were not enough. Return the minimum possible answer to the person, the first. Okay, from 0 to 2 by 1. Yes. Yes, I need it. Okay, let's see why this is not working. Well, I suppose this is working. Print test and advance of test. save this. So first two, it's also false. Interesting. Why would two be false? Also, this is kind of weird because this one is actually only 0, so it should be then k plus 1, I think. Or did I mess it up? K plus 1. Oh, I'm not out of range, so seems not, but yeah, let's maybe use it as a range, and then I don't have to. Or do I have to? If I have 2, 2 plus 0, that's 1, so I start at the right one. No, this is okay. If I only use 1, then I want to use only 0. This is good, so. But you cannot have 0. That's it. So test cannot. Test 0 means. Okay, so test 0 is test plus 1 actually. Something like this. Queries of I is out of range. I should do this. It's again not good, so. So, I try with 1. Why do I try with 1? Exactly. So, first one I tried test is equal 1 false. What? Line of queries is okay, it makes sense. So 0, 1, 2. I have 2 of them, so I have I have 3 of them, so I have 2 and 0 and 2. That's 1 here. So I test 1. Then now I messed this up. So if I test, okay, if I'm testing 1, that means that I want to try 2 of them actually. 0 per 0, 0th and first. So this will be 2 for, I'm not out of range, okay. This will be 2, and for I in range 2, that's 0 and 1, queries left right value, 0 and 1. Current pulse. And if current is greater than silly. It was good all the time, it seems. What's now? Okay, I don't need to print it. But But this seems like forever loop to me. So but what was that? So this one was true. So this one was true, 1 and true. Okay. If this is equal to 0, then I'm breaking them out. Else, right is equal to test. And test here was 1. So I have 0 and 1. 0 plus 1 is again 0. Advance of 1. Yes, here they must not be 0, because if they are 0, then if they are equal, maybe something like this. Don't really get it. Almost. Expected 0. What? Okay, so if sum is already 0, I don't need to do this. But why isn't it like... Wow, yeah, I'm not negative, so still mistake. So if sum of nums is equal 0, I return 0. That's it. Maybe. And perfect. So, whoa. What can I say on this one? Well, actually it doesn't look that big, so only 40 lines of my not ideal code. So let's try to get this more. Does it fit the screen? Well, not really, but yeah. So here's the code again. I have that advanced that checks if it's possible to do it for that K. And maybe I could use some caching or saving something, but yeah, I could. In this example, I could save possibly for quite a few queries. Yeah, for quite a few queries, so well, I think I had enough. I don't want to optimize further. I'm happy with this, but we could have some memory. So for each try, especially if we need to go further. So if this one was not good, then we need to go there. We can save and continue from this one for the line sweep. So yeah, but let's see what's this. This will be interesting to determine. So time complexity space complexity. Well, space complexity should be all of n because that's line sweep. That's line sweep and time complexity. So since we are searching on the queries, it's log q times we'll do the search, but this times I would say so we need to do the line sweep part. That's, let's say q, yeah, q plus n, but it's not actually q, like something like q plus n, something like this. Interesting. Well, I'm doing binary search. No idea. I would say this because I need to binary search it. But again, do I binary search? Well, I do binary search. In worst cases, I don't know. I think it's something like this. So, yeah, maybe this together is, yeah, really not sure about time complexity for this one, but I'm just glad that I got it, that it's accepted and it works. So yeah, if you have any questions about this one, feel free to write them in comments. I appreciate you for following, and see you in the next one.